Boxer is a system for examining and comparing the results of machine learning classifiers. It allows for detailed exploration of classifier results by enabling users to identify subsets of instances and compare the performance on them. Boxer allows a user to combine multiple views and connect them with flexible selection mechanisms. Boxer provides a classifier performance view that provides a closer view of a selected metric. The boxes of the chart can be clicked to select the instances they contain. Here, we select the instances correctly labeled by this classifier. Left-click creates a selection. The selected instances appear across Boxer's interface. We can see it in the performance view of other classifiers. For example, here we see that this classifier has gotten some of the selected items wrong. If we add another view, the selection is also shown. Here we see a histogram of actual classes. We can see how the selection of items classified by the first classifier is distributed. Almost all views in Boxer allow for the selections to be created and displayed. For example, we can click on a bar of this histogram and see where its instances appear in the classifier performance view. Boxer supports two active selections. We create the first cyan selection by left-clicking. We create a second pink selection by right-clicking. Here, we've selected the items correctly classified by a second classifier. This allows us to compare between the selections. The Selection Controls panel allows us a history of our selections. It shows how much the two selections cover the range of instances, and it shows how much the selections overlap. The selection controls allow us to perform set arithmetic on the selections. Here we intersect the two selections, creating a new selection that is the set of instances that both classifiers got right. We have trained a classifier that determines whether a document was written before or after the start of the English Civil War. We are interested in whether short documents are easier to classify than longer ones. We select the short documents by unioning together their histogram buckets, and then select the longer documents by unioning those histogram buckets. In the selection performance view, we see that there is some difference in the performance between these two categories. We can perform a similar experiment to see if documents written close to the cutoff date are harder or easier than the rest of the documents. Here we see a larger difference between the documents written closer to the cutoff date and further from the cutoff date. We use Boxer to explore fairness issues in classifier construction. We train classifiers to predict whether a person is likely to commit a crime in the next 2 years. One classifier, called C3, beats the baseline across all metrics. However, we are concerned that it achieves this performance by being unfair to African Americans. To explore this, we look at a histogram of race and select the Caucasians and African Americans and look at the performance on this selection. For C3, we see that the performance is very similar in terms of accuracy. However, if we look at precision, we see that precision is much higher for Caucasians and that recall is much higher for African Americans. If we look at this data for in the confusion matrix grid, we can see this again. We see many false positives for African Americans, many false negatives for Caucasians, and very few true positives for Caucasians. To explore the bias further, we'll consider the effects of gender. We use a histogram to select females. We intersect this with African Americans to create a set of African American females. We see that there is 0 recall with many false negatives. we can see if there's a similar effect for males. We select males, we select African Americans, intersect these, and see a category with 100% recall. Bringing back the previous selection of African American females, we can see the dramatic difference of 100% recall for African American males and 0 for African American females.